Okay, so what if we could build a machine that actually thinks? I mean, really thinks. It's a question that has obsessed people for, well, millennia, and it's taken us on this incredible journey, from ancient philosophy all the way to the smartphone in your pocket. So today, let's dive into that quest. We're going to trace the long, winding, and totally fascinating story of artificial intelligence.
So everything we're about to talk about really boils down to this one single question. Can a machine think? For centuries, that question has been this beacon, guiding some of the greatest minds in history. And what's wild is that the first real attempt to answer it didn't involve a single circuit board or line of code. Nope, it just started with an idea.
So the first big swing at building a thinking machine, well, it had absolutely nothing to do with computers. The goal was way more fundamental than that. It was about creating a perfect, bulletproof formula for reasoning itself. I mean, they wanted to literally write down the laws of thought.
Okay, so our journey really kicks off way back in ancient Greece with Aristotle. This guy wanted to nail down the rules for what he called right thinking, and his big idea was something called the syllogism. It's just a simple, logical structure for an argument. So take a look at the example here. Premise 1, Socrates is a man. Makes sense. Premise 2, all men are mortal. Yep. Conclusion, therefore, Socrates is mortal. See how that works? If your first 2 points are true, the conclusion has to be true. And boom, that was the birth of formal logic.
So Aristotle lays this incredible groundwork, right? But then for like 2,000 years, not much happens. Logic kind of sits on the shelf. Then, bam, the 19th century hits and things just take off. As you can see here, this guy George Boole comes along and does something brilliant. He turns logic into math. He creates a whole system based on just true and false. And that is the absolute bedrock of every single modern computer. Then, a bit later, Gottlob Frege pushes it even further, giving us a system to talk about objects and how they all relate to each other. These weren't just brainy exercises, you know? These were the actual tools that would one day let us build a thinking machine.
All right, let's jump forward to the 20th century. Because all that abstract philosophical logic, it's about to meet a machine that can actually do something with it, the digital computer. And this, right here, is the moment that the dream of AI finally starts to feel real.
So, picture this. It's the summer of 1956. A small group of brilliant scientists get together at Dartmouth College, and their proposal, I mean, it's not just bold, it's basically science fiction come to life. They had this crazy belief that they could make machines use language, form concepts, solve problems, all the stuff that was supposed to be for humans only. And right there, they gave this audacious new field its name, artificial intelligence.
And those early years were just electric. Seriously, computers started doing things that the experts swore a machine could never do. Every single breakthrough was like this giant told you so to all the skeptics. The pioneer John McCarthy captured the feeling perfectly. He called it the look ma, no hands era. And that's exactly what it felt like.
But then they hit a wall, a really big one. See, the problem is that pure formal logic is like a perfect crystal. It's beautiful and ordered, but it's also incredibly brittle. The real world? It's not a crystal. It's a messy, chaotic cloud of uncertainty. Logic needs things to be 100% true or 100% false. But our world is filled with maybes and what-ifs and probablys. And this purely logical approach, it just couldn't handle the mess.
So this huge limitation forced everybody to kind of go back to the drawing board. It was a massive pivot. They realized they needed a whole new tool, one that could handle not just black and white certainty, but all the shades of gray that make up the real world.
So to deal with all that real-world messiness, researchers turned to something new. They moved away from the absolute certainty of logic and started embracing probability. And you can see the difference right here. Logic can only tell you Socrates is mortal, full stop. But probability lets a machine think in those shades of gray. It can say, hey, there's a 40% chance of rain, which, let's be honest, is a lot more like how we actually think about the world.
And the key insight here came from a pretty unlikely place, the mathematics of gambling. Yeah, seriously. An idea from the 18th century called Bayes' rule gave AI this incredible new superpower, the ability to learn. It's basically a mathematical way to update your beliefs as you get new information. Think about it like a doctor making a diagnosis. They have an initial idea, but as new test results come in, they adjust their thinking. That's Bayes' rule, and it became absolutely fundamental for building smarter, more adaptive AI.
Okay, so this brings us to the next great leap, a really game-changing idea. What if instead of us having to painstakingly program every single rule into a machine, we could build a system that learns the rules for itself, just by looking at a ton of data?
So, if you want to build a learning machine, where do you look for inspiration?
Well, you look at the best one out there, the human brain. And this comparison is just fascinating. Check it out. When you look at raw speed, a computer chip is 1,000,000 times faster than a neuron in your brain. But the brain has a superpower. Just look at the interconnections, trillions of them, all firing at the same time. It's massively parallel. So the big takeaway was, hey, maybe we shouldn't be building AI like a super-fast calculator. Maybe we should be building it more like a brain.
And this idea inspired a whole new approach called connectionism. The goal was to build artificial neural networks, basically systems made up of lots of simple digital neurons all connected together. So instead of trying to program in the rules for what is a cat, you just show the network thousands and thousands of cat pictures. And over time, the network just learns the patterns on its own. This was a massive, radical shift. We went from programming a machine to teaching it.
Okay, so we've got logic, we've got probability, and now we've got this idea of learning from data. Where's this whole journey brought us today? Let's take a look at what modern AI, built on all these foundational ideas, can actually do.
Well, for one, in the world of strategy games, AI is, well, it's superhuman. For decades, chess was seen as the ultimate test of human intelligence. Then in 1997, IBM's Deep Blue beat the world champion Garry Kasparov by searching through billions of possible moves. And checkers? A program called Chinook didn't just become the world champion, it completely solved the game. That means it proved that if both sides play perfectly, the game will always be a draw. These weren't just fun little experiments, they were huge milestones. And modern machine translation is a perfect example of this new way of thinking. This quote here really says it all. The computer that translated this Arabic headline, it doesn't understand Arabic, not in the way we do. It has no idea about grammar rules, it just knows statistics. By analyzing trillions of words, it learns which words are most likely to follow other words. So the computer scientists who built it, they're not linguists, they're statisticians. It's a whole new world.
And finally, robotics is where all of these different ideas, logic, probability, learning, they all come together. A modern robot, like the one we're seeing here, uses its sensors to perceive the world around it. It uses probability to deal with our messy, unpredictable reality. And it uses behaviors that it learned from data to do really complex stuff. It's kind of the ultimate culmination of this entire journey.
I mean, think about it. We have come such an incredible way. From Aristotle trying to map out logical arguments to systems that learn from data on a truly global scale. And as these systems get more and more powerful, some people are starting to talk about something called the singularity, a point where technological growth becomes uncontrollable and irreversible. It just leaves us with this one massive question. In this timeless quest for a thinking machine, what on earth comes next?